So we're going to talk about periodic functions. So a function f is periodic if there is a positive number p such that whenever we take theta, and that's in the domain of f, and we add p to theta, then that is equal to f evaluated at theta. All right, so to give you an example here, so let's take the unit circle. Okay. And so we're going to do a point. We're going to go around to about right here. And this is 1/2 square root 3 over 2. So that angle theta here looks like pi over 3. Okay? So if I do the sine of pi over 3, the sine value, that's the y value, that's square root 3 over 2 for the unit circle, right? Now what I want to do is I want to test, what about the sine of pi over 3 plus, okay, let's take a number, okay, pi, 2 pi here. Okay, so this 2 pi here, if I add 2 pi, what's going on? So if I add this 2 pi, what's that going to do to my angle? It's going to rotate all the way around until I get right back to where I was. 2 pi. One full rotation. Okay? So what does this tell me? That tells me that the sine function is periodic. This is also equal square root 3 over 2. So I have the sine of pi over 3 plus 2 pi equals the sine of pi over 3. So that tells me that p is pi over 2 for sine. Okay, so in general, the sine of theta plus 2 pi times some integer k is equal to the sine of theta. Okay, same thing's true for cosine. The cosine of theta plus 2 pi times some integer, some integer multiple of 2 pi is equal to the cosine of theta. Okay? So this will help us out in our calculations, because you might have something where it's like 3 pi or pi over 3 plus 2 pi, and they combine this, and maybe this is, I don't know, maybe that's 6 pi over 3 added, so that's 7 pi over 3. So they might ask you to calculate, what is the sine of 7 pi over 3? Well, how do you do that type of problem? You take this, and what I would do is I would just start subtracting off 2 pi amounts until you get something, similar to this right here. So just subtract until you get it worked out to where it's something where it's one of those ones that we have memorized. And you get that pi over 3, and then plug that in here because you know that sine and cosine are periodic. Okay? So in general, right, so we have sine of theta plus 2 pi equals sine of theta. We also know cosine of theta plus 2 pi equals cosine theta. We know cosecant theta plus 2 theta, or 2 pi, is equal to cosecant theta. We know that secant theta plus 2 pi equals secant theta. Okay, so all of these have fundamental period. That's the smallest number p such that the above equality is true. The fundamental period of 2 pi. And then the last is the tangent of theta plus pi equals tangent theta. I'm sorry, theta, not pi, tangent theta. And then the cotangent of theta plus pi is equal to the cotangent of theta. These have fundamental period of pi. Okay, so we've got two different options for our 6 trig functions, right? And tangent and the reciprocal of tangent, those have fundamental period of just pi, right? So multiples of pi get you the same output. So just to make sure we can do these types of problems, if I had like the tangent of 5 pi over 4, what do I do here? Well, I see how I can break this up, okay? See how I can break this up. If I take 5 pi over 4 and I subtract away a pi, what do I get? I get 5 pi over 4 minus 4 pi over 4, which is pi over 4. So I can rewrite this as the tangent of pi over 4 plus pi, okay? So what does that tell me? Since my fundamental period is pi, this is equal to the tangent of pi over 4. Now the tangent of pi over 4, this is equal to the sine of pi over 4 divided by the cosine of pi over 4. So hopefully we've got those memorized. And so the sine of pi over 4 is square root 2 over 2. The cosine of pi over 4 is square root 2 over 2. A number divided by itself is 1. Okay? Let's do one more just to make sure we got it. So let's do the cosine of 5 pi. All right. So the cosine of 5 pi. Now, I need to rewrite this as the cosine of some angle plus 2 pi k, right? So if I take 5 pi and I subtract 2 pi, what do I get? I get 3 pi, which is still greater than my 2 pi, my 1 revolution around the circle. So I'm going to subtract another 2 pi and I get pi. So what does this tell me? This tells me it's cosine of what? It's pi plus 2 pi times, how many 2 pi's did I have? 1, 2. Okay, so 2 here. So that's what? Cosine of pi plus 4 pi, right? That's like going around the circle once and then going around it again 2 times, okay? 4 pi is going around the circle 1, 2 times, okay? And then I go around pi like it asked me to do here. So this is equal to the cosine of pi, which the cosine of pi, when you think about a unit circle, if I rotate all the way around, what is the x value over here? The x value is equal to -1. Okay. So hopefully that kind of helps you out as you go through and you're dealing with finding exact values using periodic properties.